Hello, this lesson is about solving absolute value inequalities algebraically. The next video will be about solving absolute value inequalities graphically. So let's start out by reviewing the concept from class. In the exploration in class, a reminder that when we looked at the absolute value of x plus 1 less than 3, we saw that this was centered at -1, and it's describing, this inequality is describing all of the solutions that are at most 3 units from -1. Now that at most could also be replaced by the phrase less than 3 units. Okay, there's that less than symbol. So here I am centered at -1, and I want all of the x's that are less than 3 units away. So if I travel in the positive direction 3 units, 1, 2, 3, I am at 2. I'm using that parentheses because we actually can't be at 2. 2 is exactly 3 units, and we have to be strictly less than. Well, there's also values this direction that are 3 units away. So all of these are less than, everything I'm shading is less than 3 units away in the negative direction. And again, -4 is exactly 3 units. It's not less than 3. So I'm using those open parentheses. So the solution to that inequality would be -4 to +2. All of the values in between those endpoints. So we use interval notation. Another example, in this then in the absolute value of x minus 3 is greater than 4, we see that the center is +3. And here we want to think about all of the solutions that are greater than 4 units away from 3. Writing on my picture down there. Sorry. Okay, so let's take a look at this on the number line. So here's our center at 3. X has, all of the values of x are 4 units away from 3. So if I go 4 units, 1, 2, 3, 4, I'm at +7. But I don't want +7 because that's exactly 4 units. I want everything that's more than 4 units. So 7.1 is more, 8 is more. Everything in this direction is more than 4 units away from 3. If I go in the opposite direction, 4 units in the negative direction, 1, 2, 3, 4, again, -1 is not 4 units, or it is exactly 4 units. We want to go more than 4 units. So all of these values are more than 4 units away from +3. So this solution in interval notation, well, starting from left to right, we want -infinity all the way up to +1, but we don't want to include any of the values in between here, but we do want to add or union +7 to +infinity. So in interval notation, that's the solution to the absolute value of x minus 3 is greater than 4. Okay, so let's take a look at what this looks like without a number line, solving these algebraically. So just like when we solve absolute value equations, we had to split it into 2 different equations, and we're going to do the same thing with inequalities. So here we have, we can split this into x is less than +2. Not or, this is and x is greater than -2. Now, why did I do that? Why do I know that that's and not or? Well, let's take a look up here. When we had absolute value of x plus 1 is less than 3, we see that we are between two endpoints. We wanted to go in a positive 3 direction and be less than that, and we wanted to be greater than what was in the negative 3 direction. So something to add in your notes about this is that we want to think of this, of the less than inequalities, as being between two values. So we could say that x plus 1 has to be less than 3 units away and greater than negative 3 in the other direction. So coming back down to our example problems, we can set it up like this. We know that we want to join those and put an and, or we can consider that we know that the absolute value of x less than 2 means that x needs to be between 2 and negative 2. Which means that graphically, if we were to look at that on a number line, all the values that are less than 2 and yet greater than negative 2, we would come up with that solution in interval notation. All right. Now this next problem, we're going to set up a similar way. This is also a less than inequality. So we can say that 3x minus 4 is going to be less than 8, and it's going to be greater than negative 8. So we can write, instead of writing this as two separate inequalities with an and, we can make this a joined inequality. So in order to isolate x, I need to add 4 to both sides. So negative 8 plus 4 is negative 4. And 8 plus 4 is positive 12. Dividing all 3 parts of this compound inequality by 3, I get negative 4/3. Make that look better. 3 is less than or equal to x is less than or equal to positive 4. So in interval notation, I'm going to use the brackets since it's less than or equal to. That means that x are all of the values between negative 4/3 and positive 4, including negative 4/3 and positive 4. So in order to verify, like, wow, I just did all of this, these steps, is this true? You can pick these endpoints and plug them in. You can pick anything in between. 0 is easy to check. 0 is definitely between negative 4/3 and positive 4. And all of those should work. If you pick a number outside of this inequality, it wouldn't work. And you can verify that. Okay, in this example, the absolute value of x plus 4 is not isolated. So that means that we're going to have to subtract 9 from both sides. That negative is still in front of the absolute value bars. So when I subtract 9 from 5, I get negative 4. This is still not isolated. This negative sign is in front of here. I cannot distribute through absolute value bars. They're not parentheses. They're a special grouping symbol. So I am going to divide both sides by negative 1. So this is the absolute value of x plus 4. Negative 4 divided by negative 1 is positive 4. And remember, when we divide inequalities by negative on both sides, that will flip. It becomes greater than or equal to instead of less than or equal to. And now we have a greater than inequality. So it's not sandwiched between two values like the less than. So a reminder, when we have greater than, we're going to have two separate intervals of solutions because we want those values to be more than 4 units away from negative 4. So we're going to split this up into x plus 4 is greater than 4, or x plus 4 is less than negative 4. So solving both of these by subtracting 4 from both sides, we have x is greater than 0, or x is less than or equal to negative 8. So if I look at this as on a number line, sometimes that number line will help me visualize how am I supposed to write this in interval notation. So here we have 0. I'll just put negative 8 out here. X is greater than 0. So let me switch to my red pen. X is greater than or equal to 0 means, okay, I want 0 and everything to the right, everything in the positive direction. X is less than or equal to negative 8 means I'm going to start at negative 8 and I want everything to the negative direction, to negative infinity. So in interval notation, I'm going to have, starting from left to right, because interval notation needs to go in order, the least values to the greatest values. The least value that works is anything in the negative infinity range up to negative 8, including negative 8, so we use a bracket, together with union 0 to positive infinity. And again, that number line helps us set this up and get that in the right order. So let's talk about the examples that you're going to try right now. I'd like for you to try and bring to class x minus 2 is less than 1. Second problem, x minus 4, absolute value of x minus 4 is greater than or equal to 2. And the last one, x plus 6, absolute value of x plus 6 is greater than negative 10. And if you need more help with any of these types of problems, you can find more examples in your book online, or you can find examples by Googling solving absolute value inequalities. You can find some more help with that, or just rewind the video and listen again.